Hi, I am Bhavin Jain. I am currently pursuing a BTech from IIT Bombay. I've completed my second year and am currently pursuing a research internship from this prestigious institute, Maritime Research Center. And I've been added a research project here, which is basically to provide another path to the problem, which is known as sediment classification. So now I'll be explaining a bit about my project. It's mainly a data science project, and it is based on the Khadakpasla Lake data, which was collected in 2019. At the time, it was collected with a purpose to solve, which is obviously sediment classification. But the method to achieve that was done using mathematical models, such as energy time model or reflection coefficient models, which are basically very heavy mathematical models. A lot of post processing of the data was done to get the final results. So now what my aim is to use machine learning algorithms to use this data to provide another alternative to this problem so that it can reduce time and can also provide us a easy method. Now, before I move ahead with my project, I would also like to tell you about the exactly importance of it. So, sediment classification is basically classification of sediment layers, which Ayush was explaining as well, and Roman sir also explained as well. So now here, what we are doing in the left, you can see the methods which are used presently to do sediment classification, which is remote sensing, uh, uh, image analysis. Then we have diffraction, we have green sieving. These are the methods which are used presently. These are more physical methods, and again, they require extensive post process. Now, what I will be using will be based on neural networks and support vector machines, which are basically ML types. So now, what will be my roadmap for this project? Now, my project output will be mainly based on five inputs, which is time of reflection, amplitude of reflected signals, energy of reflected signals, reflection coefficients, frequency of sonar waves. Now, all of these can be calculated from the data, which is the form of data you can see on the top right corner. So basically, I've been handed signal amplitude values from the sub bottom profiler, which was the instrument used to collect the data. Now, using the Hamiltonian transform, we can calculate all these values which are mentioned on the top left. And later, I would be dividing this data into different parts to get my training data, testing data, and validation data for my final ML project. Currently, I'm in my knowledge collection phase where I'm trying to understand what the data exactly is and trying to calculate these values of parameters. I'm moving ahead to the course of this internship. Now, this my project holds a lot of future potential, such as it can, in the future, if this is successful one type of data, we can incorporate other types of data. Also, we will need to increase the accuracy of algorithms such that it can be used for high-level research operations. Now, another issue with sediment classification or any research method is which is based on ground is that it requires a lot of physical costs and time. So if we use methods which do not require that much on physical interference, such as remote sensing, then we can also eliminate the issue of physical data collection. This can all be done remotely, which will be a very big change in the methods for calculating sediment classification. So now I would like to end my presentation. Thank you for listening to me.